As I edge ever closer to being in a position to be able to get this boat set up downstairs in the workshop, I've been building a stack of boat frames over the last week, and that is what you can see surrounding me here. So in this video, we're going to take a look through the process of building these boat frames, and I'll walk you through how I do everything from start to finish. We'll also take a look at some of these frames on an individual basis and see where they sit in the boat and how things differ with them. By the way, I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Barrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. So we start out the process on CNC machine. This machine is getting used quite a lot at this early stage of the build. There will come a time when this machine sits dormant and all of the work that will continue on the boat will take over by hand, and that'll be quite a nice stage to get to, but right now in the early setup stages, this is a huge asset to the work that I'm doing. So I'm fixing the boards down onto the machine, and I've tried various different ways of doing this. You might have seen me hold these down with physical clamps. The process that I've arrived at with this is one that I actually did very early on when I first got the machine, and that is just to have my MDF spoil board held down on my machine, and then I'm screwing the solid timber board to that. It's actually a really secure, reliable way to hold things down. You've got nothing that's going to get in the way of cutters, which means you can then use the extraction hood whilst cutting. I'm still using these 3/8 compression spirals for cutting solid wood. Definitely recommend those for an application such as this. The finish that's coming off of those parts. Now that I've got my tool paths refined and my hold down method really dialed in, the finish is really nice on these, and you'll see that in just a bit when you see some finished parts. So get the tool zeroed and then get our components cut out. You can see the way that I'm nesting these. I've done all of this nesting manually, and I will position these parts in exactly the same way that you would do if you were cutting these on a bandsaw. Position them according to the wood grain and make sure that the orientation of the components is correct for the strength within the boat, which is basically pretty much every time you want straight grain down the longest sectional run of any given component. And we want to keep our main frame components, particularly the bottom framing, right to the outside of that board where the nice straight grain is. You can see the finish there that I'm getting on these parts. Really secure hold down with that onion skinning method, and really great finish and amazing accuracy. When these parts go onto the assembly table, everything's fitting really well. So I'm pleased with that. That's a definite refinement to the process, and that's as good as you're ever going to get it, I think. So once cut, the board gets then removed from the machine. And again, the releasing of parts, I've done this a number of different ways. I used to put this through the sander and thin off the back side of the board, which would then release the parts from the board. That means that I've actually got to sand the entire board down, and I found that to be a bit of a waste of time, a bit unnecessary use of my machine. So what I've been doing now is just running a little flush trim route a bit round from the back side of the board, releasing all those parts individually, breaking up the stock, and then sizing my parts after that. Any parts that still need a little bit of a neaten up after I've just done that flush trim router bit by hand, I just use a flush trimming bit on my router table, and I just finish off the final edges of those parts. This process has been working really well for me, and this is the kind of balance that I've found that fits best for all. A nice little efficient system. So once they're released and the edges are cleaned up, we then go over to the sanding machine and I take those parts down from their sawn thickness, which is around about 27 to 28 mil, down to their final dimension, which is 22.25 millimeters, but I'm aiming for anything between 22 millimeters and 22.5 millimeters. That's perfectly fine. So you can see my process there for releasing those parts from within that nice wide board of utility that got me a good stack of parts out of that board. Now, one of the things that I've been doing is, as I mentioned, I've been manually nesting all these parts. So I'll go out, I'll take a look at the board, I'll draw it in CAD, and then I'll manually place all the parts. It's quite a manual, long-winded way of doing things, but it means I can get the parts and the grain exactly what I want per component. You'll notice on this board here that there's a slight split down in the tail end of it. So what I actually do is when I draw the board out in CAD, I'll draw that split in, only loosely. It's only got to be roughly positioned, but then that allows me to place parts to make sure that I don't have anything sat within where that split is. And you can see the orientation of the grain throughout that curved side frame there. We want that running straight through, so we've got minimal grain run out along the full length of the part, and maximum strength and rigidity in the correct orientation. And I haven't been engraving the part numbers on these parts. I find, to be honest, as a bit of an unnecessary step. It means another tool change in the process. I've just been writing these on as I do them by hand using a pencil. You can see a stack of finished parts there. You can see that grain orientation running lengthways through the components, and really nice finish to them. I'm really pleased with how they're coming out. It's frame 11 getting assembled on the frame construction table. And you can see the location of those parts there. Then we get everything laid out and masked up for the dry fit, ready to epoxy coat and glue things up. So I'm adopting this two-step bonding process throughout everything that I do within this boat. I'm using this more and more in all the work that I'm doing, to be honest. And it's just a really good working practice for a number of reasons. It prevents the drying out of any glue joints as the wood absorbs the epoxy that is within the glue joint. That can have the effect of drawing the glue away from the joint, and then you end up with a dry joint, which is not what you want. So by wetting out the parts with unthickened epoxy first, that just helps it to sort of pre-soak into the wood and prevent that from happening with the joints. It's also a kind of double covering your back factor, because in the event that you may have any little voids within a glue joint, and that does happen sometimes when you don't get things fully pressed together, in the event that you do have a little void in there, you at least know that all the faces within that void internally are still epoxy coated, so you've got that kind of backup of protection there. So I personally think this two-step bonding process is just a really good working practice to adopt. Once that epoxy's kicked and just tacked up slightly, so ideally we're looking for sort of sellotape tackiness to that, I'll then thicken the epoxy that's left in my cup with colloidal silica, which I use for bonding in any scenario where I've not got a particularly on display bright finished component. If I was doing the topside planking, for example, we'd use a slightly different thickening agent, but colloidal silica is good for all these general bonding applications. We'll thicken that. I'll spread it out with a notched spreader on the surface, which again gives me a really even glue line all across the surface, prevents unnecessary squeeze out, and means that I've got a good even coating and a nice uniform glue line across the whole joint. The joint then gets pinned together with these little stainless pins, and I'm just purely using these to prevent slippage of the part when I clamp it down. I've just found this system again works really well, nice and quick and efficient, and they can be backed out once the epoxy has kicked. So you'll see here that I'm aiming to assemble the joints in a lateral motion so that I'm compressing that glue joint as the part goes together rather than shearing it off by pushing parts down from above. And then we go again over with a notch spreader, get a nice even glue line on there, and then we can put our gusset into place. Pin that down just to locate it, and we're good to go. Good little tip for you here: if you wear 2 pairs of gloves, then you can cover your back if you happen to make a little hole in one of them, but you can also pull off the first pair if you've got to do some clean work in the intermediate stages where you don't want to get glue on your clamps. So pull off the outer pair of those gloves and then you're good to handle your clamps without getting them covered in epoxy. The following day, once that epoxy's cured, we get those pins pulled out so I can remove the clamps. I'm just using a set of pincers here to lever those out, and a little piece of ply just to protect the surface faces of the wood. You can then also pull those masking tapes off, and that just helps us a little bit with cleanup regarding the frame gusset edges. Then the frame gets lifted up off the construction board, so this is semi stuck down because we've got that polythene there. It does lift quite well, and because I'm using those plastic dowels for alignment, they seem to break the glue line quite nicely, so a little bit of a leverage there, and that just comes away nice and easily. Again, this is a process that I've kind of done various different iterations of it throughout the project, but this seems to be working really well. Get that flipped over. And then you can see that to release these plastic dowels, I just put a set of mole grips on and I give them a slight tweak, a little rotation. That just breaks the glue on them and then allows me to pull them out without any breakages. And I've managed to use that same set of pins for every frame that I've done so far. So that would be my recommendation, I think, versus the wooden dowels that I originally thought I was going to use. So then we're on to the next frame. Everything gets dry fit first. So I knock those dowels through, locate all the parts, make sure that I'm happy with the positioning of everything. Locate the fillers, locate my side frames. And locate the deck beams, which, as you can see on this frame, are quite short because this is again one of the ones from the open cockpit portion of the boat. Then we can saw the gussets down. So you'll note that I am making my gussets here from solid utility, and they would originally be spec'd for plywood, which would mean that you wouldn't have to do this resawing process. I quite like the idea of doing these from solid wood and kind of filling in the little offcut holes that would otherwise be probably wasted within the utility boards that I've got. So I'm resawing these here, and you might think this is quite a dangerous practice. It certainly looks like a bit of a precarious job to do, but by adopting a couple of different good working practice techniques and make this a hell of a lot safer than what it actually looks like it might be. So if you take a look at my finger positions here, I'm very careful to make sure that my fingers are on the outside of the stock and I'm not putting them anywhere in front of the blade. So the idea is really that you are not going to get yourself into trouble even if you have an instance where you might slip here. So as soon as I'm able, I'll get my fingers positioned behind the blade and I'm just using those to push against the fence. All of the forward pushing motion in line with the blade is done with a push stick. So it means that if anything suddenly gives way and goes, it's only the push stick that's going to end up in the blade and not my fingers. So we start off with those gussets at around about 27-28mm thick. I resaw those into 2 halves and I can just about get the 12mm gussets for the chimes and the keel out of a board. If I get that resawn nice and evenly, I can put those through the sander, I can bring them down to thickness and I'll get 2 keel gussets out of 1 cutout piece. That's been working really well, nice and efficiently. And then the shear gussets up at the deck line, those are a little bit thinner at 9mm, so they're okay, they just have a few more passes through the sander. We then go over to the router table and I put a little radius on those that's going to be on the internal exposed edges just to soften those off. I'll do a bit more of this later on down the line when the frames get ready to go into the final boat, but I'm just trying to do as much of that as I can because once these are glued on it's going to be difficult to get a little radius round over bit into those. Get them softened off nicely and it's just going to make everything look a little bit neater and cleaner. There's a little interesting shot for you. So this is using some 5-minute epoxy just to put the second side gussets on before machining operation. This is what the camera sees, and then this is what I actually very often have to do in order to get those shots. So I quite often see myself straddling cameras, trying to use a chisel whilst monitoring the screen. In this case I was doing it with some G5 epoxy, so thought it might be interesting for you guys to see just what goes on behind the camera. Then we're on to carving. I've done a load of carving this week, so I've got a stack of frames nicely carved, and again making refinements to this process every time throughout the roughing and finishing process. So I've had a few people ask how much time exactly does it save when you are pre-beveling these frames on the CNC machine, and I thought this little bit of footage here was a really good opportunity to explain how that's actually quite a difficult question to answer. So if you guys have built boats before, you'll know 100% that there are any number of different delays that can be caused in the beveling and fairing process of building a boat. You can have errors that are induced within the lofting stages of the boat, and you can have that in the setup stages of the boat as well. And when it comes to fairing in and setting in your longitudinal timbers, the time that can take can vary massively from one boat to the next, and sometimes you'll have errors that lie there that you can't really determine where they came from or what caused them. So a lot of the time when you're setting in longitudinal timbers, you'll actually just work around it. You'll have to fair around it, pack things out, shim things, whatever. That can take a sort of an unquantifiable amount of time, really. It can vary for any number of different reasons and errors induced in the original plans or at any stage during the build. Now, one of the benefits that I believe I'm going to have with pre-doing this fairing process is A, that I'm not going to induce any of those initial errors down the line. So there's a potential saving there, but it's a saving that's difficult to work out because fairing and setting in topside patterns may take a short amount of time, it may take a long amount of time if you're doing it with the traditional method. But then when I was doing this process this week, I realized that actually here's another massive saving that you kind of factor into all of that. And here you can see that what's happening is my CNC machine is working away, beveling that frame. Whilst I'm doing something else, you can see that I'm sanding frames here, I'm cleaning up parts, I'm actually doing other work whilst this machine is beveling my frames. So not only is this potentially saving me the time of having to bevel that frame down the line, it's potentially eliminating any errors that would otherwise be, or could otherwise be, induced from the manual method. But probably best of all, it's doing it whilst I'm actually doing something else. So it's almost like you've got two people working on the project at the same time. So I thought this footage was a really good opportunity to be able to kind of explain that process to you guys. And we'll really see the benefits of that further on down the line. And let's remember that this by no means is taking over from the manual and skilled process that is still going to follow on down this boat. I know that some people think that CNC is the answer to everything, but it is by no means a replacement for the manual skills. And we'll see that as this project progresses. There'll come a time when this machine sits dormant and all the handwork takes over, but it will set up a core foundation that will work really well for the project and really help move things on. So you can see the first 3 frames that I did there. You've seen a lot of work with those before. You can see that we've also got a stack now of all the frames that form the cockpit element. So these are all open-topped frames that are going to form the portion of the boat that I sit in. You can start to see the shape of that boat there just coming through with the stack and the varying dead rise throughout the boat. So we've got frame 5, 6, 7 and 8 there. Some of these are carved, some of them are still awaiting carving. And then we've got some of the frames from further back in the boat. So we've got 11 and 12 here, which have just got gussets either side. They've not got bulkheads at all on these frames, and these are in the sort of engine bed area of the boat. If you manage to tune in to the live stream, you will have just watched me. As you can see, I've still got it all set up. I've just done frame 13 live, so if you didn't get a chance to watch that, check in and watch that. I'll answer a load of questions about the boat as well throughout the process. So built frame 13 live. You can see the really nice shape to this frame now. This is right back just before the transom. We're back to having a deck beam there because we're just aft of the engine hatches. We've got a nice wide keel gusset there because the keel widens significantly in this area. But look at the curvature that we've got going on here in the tumble home. That's going to be a really nice frame, especially when we see it carved. Frame 10 is here. Frame 10 is a bit of a different one and a slight exception to the rule. So you'll notice that frame 10 is in 2 halves, and what actually happens with frame 10 is that it's going to get cut off eventually here. So where our stringers go through our frame, this middle portion of the frame is actually going to be completely removed, but that's going to happen after I've planked the hull. And the reason for that is that it sits up in a portion of the boat, which we might be able to just see on the model. Frame 10 sits up in this part of the boat here, and so the section internally of the 2 stringers will get cut away because that's where the sort of sump and the transmission for the engine is going to sit down in, right close to the bottom planking. So what we're actually going to do with frame 10 is put a temporary gusset on it just to tie the 2 parts together. We'll use this for the purposes of forming our bottom planking, and then we'll cut it out further on down the line. So that's a look at the stack of frames that we've got going on. There's 2 more in parts just over there. Frame 4 and frame 9, which are the 2 other bulkhead frames. We've got this big one here which is going to have to be veneered and then laminated on the inside for that same open aperture that we did with frame 2 previously. And then we've got frame 9, which is going to form the back of the rear seats in the aft end of the cockpit, and it's also going to form the primary bulkhead between the cockpit and the engine bay. So we'll do those two next, then we'll be on to doing the transom. That'll be a good bit of fun. Okay, so that is the majority of the frames done. I've got to do 4 and I've got to do 9, the 2 veneered frames that are left. We will cover that in the next video. We'll do some more resawing of the veneers to get them ready to cover the bulkhead portions, and we'll do that lamination section again that you saw in frame 2. If you caught that video called, I think it was called Building a Beautiful Boat Frame. So we've got 2 more of those to do. Then we'll be into probably doing the transom following on from that, and then we'll do the stringers. So we're slowly getting all the components together to be able to do a proper setup downstairs, and that will be a really exciting stage to get to. So thank you for watching. I hope you've enjoyed this video. Hope you caught the live stream. If you didn't, you should be able to drop back and see some of that if you've got time to watch through it. It's quite long, I know. As always, want to say a big thank you to the patrons that are offering additional support to this project. It really helps me to move things on and keep a bit of a steady income from all of this stuff, which is quite critical in making all of this work. Really appreciate that. Thank you guys, and thank you for watching, and I will catch you in the next one. Cheers guys.